Each year, drowsy driving accounts for 100,000 crashes, 71,000 injuries, and over 1,500 deaths according to the National Safety Council. All of these deaths are completely preventable, and our innovation seeks to stop them for the most vulnerable drivers. NeuroDrive was designed to tackle drowsy driving more effectively, especially in the trucking industry where truckers undergo long hours over extended periods of time.
And are the solutions used working well?
Sometimes it works. Sometimes it works about drinking water, finding a safe spot to take a rest.
Do you always have time to take a rest in that?
Not all the times. If you're in the middle of the city, there's no place to stay to park the truck because you can't park there.
NeuroDrive is an EEG device capable of detecting real-time electrical brainwave signals through dry electrodes in contact with the surface of the head, namely with a reference sensor in the front, a pair of electrodes over the prefrontal cortex, and a pair of electrodes over the temporal parietal lobes of the brain. NeuroDrive was designed to be minimal and lightweight to maximize wearing comfort for long road trips. It is also equipped with a 3.7-volt, 2,000 milliampere-hour lithium-ion rechargeable battery capable of lasting over 20 hours, a coded Arduino board, LED lights to show battery level and electrode connectivity, and a speaker to alert the driver from drowsiness.
As you can see, the headband straps are adjustable and have a silicone inner strip to minimize sliding. The prototype uses a Arduino Uno as the processing chip, though the final version will use a smaller, more specialized chip to decrease cost and size. In the case that a driver becomes drowsy, the speaker makes a beeping noise to alert the driver. The final compact design will include the speakers, processing chip, and rechargeable battery in a space within the headband, allowing for NeuroDrive to be worn alongside other headgear, including hats.
To develop and verify our algorithm for detecting drowsiness, we used data that we collected through a commercially available EEG headset. We built on frequency domain analysis techniques similar to the Fourier transform, which allow us to split the incoming data into multiple brain waves, such as alpha and beta waves. We then use a moving average filter to clean up the noise in the data and build a continuously adapting distribution to detect peaks in beta and gamma waves, which we found to be the best predictors of drowsiness.
Innovations to combat drowsy driving often include detecting eyelid drooping or steering wheel behavior changes using cameras and movement sensors. However, these innovations typically vary from person to person and are often subject to face interference from different road conditions. The most common solution is to just pull over and rest, which is very reactive. On the other hand, NeuroDrive is a proactive rather than reactive solution, as it detects drowsiness through brainwave changes before physiological symptoms manifest. NeuroDrive is also more accurate than other innovations as it continuously calibrates based on the individual as more data comes in.